We're not working with a machine that is really designed for this kind of thing. Of course, this is not a recommendation. This is just for my own personal note-taking. This is just my experience with the machine. I do not know what I'm doing, and following my instruction will be dangerous. Will be dangerous. What can I say? There are some resources I would like to shout out. I got all these results by searching this on Bing. Got Fusion, Post for 360, mill turning on Tormach, and this link right here. So I'm basically cheating off of Dragonwrath Innovations. They have a great tutorial for the mill turning, and they go into much more depth than I have. I recommend watching this video. Maybe this works. So I'm going to post-process this. So there's a variable in the post processor that's like capability milling, and there's capability turning. But you want to change this variable here, capability turning. It was previously capability milling. I could show you the default one. What's this? The default one is here, the Tormach. This is an unmodified post processor, and you can see here it says capability milling. Some other changes that you need to make are for the feeds and speeds, you can't use constant surface speed or use feed per revolution. So I have those unchecked, and I have them like mill parameters, RPM, and feed rate. Turn the coolant off. For the retract distances here, I have a safe retract, about 3 inches, 3.5 inches. So when we move to the next tool, I don't crash. Always making sure that all the tools are related. So all of these tools, when I run the simulation, it's the same tool. Making sure that your tool that you're using matches the one that's actually in the machine. Sometimes chips build up. When chips build up, I have to stop the machine, clear out the chips. To speak of the current post-processor limitations, I am with this strategy and this post-processor, when you just change the capabilities turning from capabilities milling, we're not able to use the left side of the vise. Now you might be able to play with the axes direction and see if it flips over. In my experience, it does not flip over. You get still like the same kind of tool path as if it was on the right side of the vise. You may be able to invert specifically the X direction. So you might write a little script and look at the specific toolpath that you want to invert. It could also be possible that within the post-processor you can change variables. Other downsides, drawbacks, threading. I cannot do threading. You probably can do threading if you have one of those tension compression threading tools and you just mount it on the table facing upwards. You might be able to tap a thread. One way of getting lathe on the Tormach without any additional equipment beyond just the lathe equipment. There's a rapid turn. Rapid turn mounts to the table, and you need to connect through the box for the power for the spindle, and it instead goes to a spindle on the table, and you can run lathe tooling in that way. The interface is a lathe interface, and you can also do threading. It's milled like in this back and forth style for rigidity issues. I presume I'm going to get a little bit of chatter at the handle of the top. That's why it's milled in this orientation. So when the Z-axis is facing down, that's the table. Imagine this as the tool table, the work table, and this is your spindle moving up and down. You can post multiple setups at the same time, and then I will move between each tool. For this example, I'm only using one tool, so G54. Clearance height is most important. That's going to post. It's going to be posted. Then I'll go to my previous examples that I have. So I have a G54, G56, and G55. I can use from previous setup, from preceding setup, and continuous machining for each of these. So I have a grooving tool. I have 3 tools here. So I'm going to run the simulation, clicking the top folder for the setups folder. And you can see how this is being run. That was a little fast. I'll play it again. This is doing the roughing. Then we're going to come back with the finishing. And some of the geometry here cannot be accessed by that tool, so it needs to be roughed out. Then we finish it with this tool. Then we have the groove tool, which is our parting tool, and it's going to come in and separate the stock for us. So using Path Pilot Hub, you can test out and see if there is any error in your G code, especially for compatibility with disallowed G code values. And you can run a Tormach controller without ever getting to your machine. I want to see the indicator come in, and we can see the toolpath that will be run. This was a lathe operation. You're going to notice that your toolpath seems to have been flipped, but that is just the way it is around these parts. When you're working with a little workaround, you need to work around what you're working with. Alright, so I want to measure the tool stick out. What I'm going to do is I'm going to set myself into a G59, and that will be our reference position. You can see I've used it before because it's still 2 inches. So at this point, I'm going to go to my offsets. I'm going to choose tool number 2. And I'm going to save the tool, the pointer length here, and the stock length will be here. So for now I'm going to use this length, and right now we are touching off the jaws of the 3-jaw chuck, so this will be 2 inches right here above G59. So this is going to be our G59 where we're touching off all our tools and stock from. And we'll see how that gets used a little bit later. Now I'm going to put the pointer, this is the chamfer mill, and point at the very tips after I've measured this tool. I've loaded up the tool. I'm going to jog it up until I can slide this underneath. And that is now 2 inches, and I can read this value 8448. So I'm going to type that in here for the length value, 0.8448, and we should get back to 2 inches as soon as I get onto tool number 2. There we go. So now we're at 2 inches, which is the truth. So this will be used to point. Okay, so now that I've pointed it out, I'm going to go to G54. 54. and then I'm going to set it at 0. Now I also have my tool length offset here, so when I 0 all of these values, it's going to be placed exactly at that tip right there. Alright, so that is good. I'm also noticing that I'm in the high belt. Usually I'm doing milling, but if I'm doing turning, I go to the low belt. So I'm going to change that out right now. Alright, so now it is on the low belt. I'm going to update this over here. Nice. So there is a correlation between the axes in a mill and the axes in a lathe. Alright, I'm going to take this value, subtract 2 from it. I'm actually going to make sure that I'm in G59 first, and then take that value and subtract 2 from it. Please let me copy. Is it Control C? Am I allowed to do that? And Control V. And then subtract 2, because that's the length of the 1, 2, 3 block right there. Perfect. And then I can change over the tool number 2. We should see it go to 2. And that's on G59. So I could essentially just copy that over to tool number 1. Alright, very good. Okay, so I have returned to G54, so that tool. So I'm going to center myself right above it. Excellent. And I want to do an air pass, so I need to shift it over by, say, 2 inches to the right. So I'm going to type in a negative X value here. I'm going to say negative 2 inches. And that should bring my toolpath to the right. Okay, and now jog it over. Jog it over to the new position. Screen over. And I could try my tool there. Always recommend doing air pass, especially when you're... So, something you should check for also is the clearance. Here I've jogged the spindle behind the tool post and just making sure that none of the jaws are going to hit. And also looking at the distance, if we have clearance for the stock material there to not touch the jaws. We are in the low speed. Stop it and let's go 250, 259 I guess. Alright, good, 500. Alright, 1000. Okay, so my chuck is rated for 4000 RPM. When I am the low position, I think the maximum speed is like 3500. So there's a physical limitation with the machine that prevents it from spinning over 4000. Which is the rating of the chuck. 2000 RPM, 3000 RPM, 3250. So the max RPM is 3,250 in the low position. So can go faster. So I'm going to jog the spindle up a little bit. I'm going to turn my the max velocity down to 5%, go into single block, and then I'm going to hit cycle start. I'm going to have my hand ready on the escape key and just go block by block. So he's gonna move now. He's gonna jog up an inch. I'm gonna start increasing my max velocity at 10%. I'm gonna exit single block. I'm still at 10%. I'm expecting it to slow down when we get above. There we go. So we started cutting operation at 15 inches per minute. So max velocity, I'm gonna leave at 50. And you can see the rest of the air path here. So I increased the feed rate 200%. I still have my max velocity at 50%. Now is a good time to shoot your lubrication into the machine. So I have the manual lubrication, so I have to give it a shot. Let's see. Current path pilot version is 2.12.3. This is a CNC 770 Series 3. Okay, we're entering a new tool path. Is retracting 3.5 inches of safe height, coming back down, starting the next tool path. This seems to be a finishing. The next tool path is a roughing tool path for the next section down. I would say that the downsides of this is that you're always loading up the stock by hand. I do not have one of those fancy stock rulers. I believe you could make a workaround. It doesn't have to be one of those fancy stock setting rulers. And around here I don't really have the capabilities to cut a whole bunch of stock efficiently. Once you get into it, it starts, you get into a rhythm, you know. If your stock's any smaller than an inch, like a 7/8, you can use the standard R8 collets. There are R8 collets that extend out of the machine. Now I have not used those. I'm not sure how well they hold on to the stock material. I presume it is as good, if not better, than the 3-rod chuck. If you want to use like a 1-inch R8 collet, it will stick out of the spindle nose a little bit, but I think in terms of cost, you really want to get started with any diameter that's larger than 7/8. It's the cheapest way to do so. What else can I say? If you could use like the tool holders, right? And if you have a height setter, you could put your stock into the tool holders, set the heights and write them down for each tool holder, and while the machine is running, start setting up removing the old stock, your finished part, putting in the new stock. And ask yourself, what could possibly go wrong? All right, I'm gonna go feed rate 100%, max velocity, I'm gonna do 5%. I'm gonna do single block, I'm gonna hit cycle start. That should start walking us through block by block. That's going to do tool 1. The tool length, you see, it's gone red. It's going to go back to 2.2. Then it's going to start up the spindle. And after that, I'm going to set up the variables that it's already set. Translate to the right of the tool holder, to the right of the turning tool. I think it is more of interest at this point to watch the turning. You're going to see on the, I'm going to be seeing on the Path Pilot what you already saw when I did the air pass. Hopefully this proves to be preferred. It'll be 3.5 inches, then it's going to be 1/2 inch above the turning tool. That was not 1/2 inch, but it seems like it was 87 thousandths. 87 thousandths, all right. I close the door so then no chips fly out to the side. Okay. Then now it's gonna move to 1/2 inch. Oh. And 1/2 inch in X. All right. I need to pay attention to the variable. I'm used to it just jogging in Z at this point. So it is 0.485 in X, so that means it's going to be cutting about 30 thousandths worth of material. So here we are. I am going to go in the exit single block. I'm going to max velocity 30%. I'm going to have my hand ready on the escape key, keeping in mind where the E-stop is. If all goes well, it's going to be fine. Okay. You can see the chip accumulation here. Okay, I have done a feed hold here. RPM, max velocity, and feed has gone to 0. I'm going to remove the chips. There's probably better feeds and speeds to be using, so then you get real chip breaking action. That will probably reduce the need for clearing the chips. Clearance is clearance, am I right? Let me know if I'm excessively clearing the chips. It's very professional. There was some design considerations for the top. As you see, if I only wanted to use that single tool, the taper of the cone for the top needed to be of a certain angle. Here's the risky part. I'm hoping it doesn't fling out at us. My hand is on the escape key. I'm ready on the E-stop. Woo-wee! Woo-hoo! Beautiful. Oh. Nice. That's so good. I want to touch it, and when I say that, I remind myself things are hot. Things are hot. Especially if you don't have the feeds and speeds down, you're not using coolant. Where did she go? Oh, I want to touch it. Oh, it's so nice. this very thin, it's hot, but it's so thin right now. I might have to, it's warm. It tips over so fast. I'm a failure. It's too top heavy. Cool. I want to see what you did. Share it. I want to see what you did.